Okay, today we're going to learn how to complete a unit circle from scratch, including all the angles and all the points that go on the unit circle. And we're going to talk about what a unit circle is, what radians are, and again, how to put it all together. So yesterday we learned about the special right triangles. We have two special right triangles on the screen here. One is the 30-60-90 right triangle, the other is the 45-45-90 right triangle. We learned for the 30-60-90 that the ratio of the legs, our short leg is x. We used p yesterday, but x. And then x times square root of 3 will give you the length of the long leg, and 2 times the short leg gives you the hypotenuse. So we're going to skip down to part C below there and pretend that the hypotenuse for this triangle has a length of 1. So now we know that 2x equals 1. So if 2x equals 1, that means x would equal 1/2 because you divide both of those by 2. So that means the short leg has a length of 1/2, which means that this has a length of 1/2 times the square root of 3, which equals just square root of 3 over 2, because we multiply the square root of 3 by 1, keep the 2 on the bottom. So if the hypotenuse has a length of 1, the short leg has a length of 1/2, and the long leg has a length of square root of 3 over 2. These are two very important fractions that we're going to be using for the next few days, and throughout this unit actually. And for the 45-45-90, skipping down to part C, seeing that the hypotenuse has a length of 1, now we have x times the square root of 2 equals 1. And we're going to set x times the square root of 2 equal to 1, divide by the square root of 2. Now I have x equals 1 over the square root of 2. However, you can't leave it like that. You have to rationalize your denominator. So now that equals square root of 2 over 2, because this equals 2, this equals square root of 2. So each leg has a length of square root of 2 over 2. So that's a number that would be a decimal if we worked out the square root of 2 and then divided it by 2, but we're going to leave that number in simplest radical form. Same with the square root of 3 over 2. Okay, so now, talking about the coordinate plane, we're going to take a whole bunch of things and put them, we're going to take a whole bunch of things here, and they seem all separate to start with, but once we start putting our unit circle together, everything will come together. So I'm going to talk now about the coordinate plane. Quick review of the coordinate plane. You have your x-axis, which is horizontal, your y-axis, which is vertical. You have your 4 quadrants, starting in the top right with quadrant 1, then going counterclockwise through quadrant 4. And then we also know that our signs of our points of our coordinates in the first quadrant would both be positive. X and y are both positive. Second quadrant, you've got negative, positive. Third quadrant is negative, negative. Fourth quadrant is positive, negative. And then we also know, well, what you also know is how to plot points in each of these quadrants. However, in this unit, we're not talking about plotting points, we're talking about angles in the coordinate plane, which is something you probably haven't really looked at before in previous math classes. So I'm going to start by looking at what the initial side of an angle in the coordinate plane is. The initial side is always on the positive x-axis. So it's always on the positive x-axis. Okay, so the initial side is always where this yellow highlighted line is, always. Now, the terminal side changes depending on where your ending side is. So this is the ending ray. Okay, this changes. So the terminal side could be anywhere. You could have it here. You could have it here. It could be in any quadrant, anywhere. It's important to note when you talk about the terminal side, that's how you tell the measure of the angle. So for instance, from here to here, this angle measures some positive number, like positive 60 maybe. Whereas this one, if it opens this in this direction, is going to be a negative angle. Let's say that's negative 60 degrees. Okay, so one is a positive, one's negative. That's because this one is opening in the positive direction, which is counterclockwise, the counterclockwise direction, so CCW, counterclockwise. If it's a negative angle, that means it's opening in the clockwise direction. So we see CW for clockwise, the clockwise direction. Okay, so there's your basic things you need to know about the unit, about the coordinate plane and measuring angles in the coordinate plane. One more thing I want to show you is if you've got an angle in the coordinate plane that measures more than 360 degrees, you can still give it a reference angle in the coordinate plane because this is the same as a 180 degree angle. However, it's actually 360 plus 180, so 360 plus 180, which is 540 degrees, but it has a reference angle is 180 degrees. So if I were talking about the coordinates, which we're going to talk about later, of the point of a point on the unit circle that's a 540 degree angle, it would actually be equivalent to the 180 degree angle. You also have what we call negative angles that do the same thing. So we might go all the way this way to here. This is a negative 360 plus 90, so negative 450 degrees. Or if you were trying to do a positive reference angle, that would actually be 270 degrees. So we're going to talk about that more later in the unit, but right now it's just a kind of intro to what the measures of these angles are. Okay, so now we're going to do a quick write, so I need you to stop, think about these questions, fill them in your notes, and then come back on and we'll talk about it. So first of all, an acute, so you've already thought about it, you're back with me. You have to think about an acute angle in the coordinate grid, in the coordinate plane. So an acute angle is anything between a positive angle between 0 and 90 degrees, and that would be in this quadrant, so that would have to be in the first quadrant. If you're talking about a right angle, you're talking about a 90 degree angle. So that's going to be on a line. The only two lines we have are the x-axis and the y-axis. So the 90 degree angle would be right here on the y-axis. And then an obtuse angle, which is more than 90, less than 180, would have to be in here somewhere. So that would be in the second quadrant. And a straight angle is going to end up here because it's 180 degrees, so that's on your x-axis. Now talking about similarities and differences between 90 degree and 270. Well, a lot of my students say they are both on what axis? They're both on the y-axis, so that's a similarity. They're both 90 degrees. One is positive and the other is negative. So that could go both ways. Both are 90 degrees, but one is positive 90 degrees, other is negative 90 degrees. Okay, so those are main differences. They're both on the y-axis. They're both right angles. One is positive, one's negative. Okay, moving on. We're going to talk about radians. I'm going to introduce the term radian to you. So a radian is the angle measure. So this measure right here, that is equivalent, if you have the radius of the circle, the length of the arc that's intercepted by this angle is the same as the length of your radius. So in other words, this length here is the same as this length here. Okay? And the same thing here. You've got a radius here and an arc here. So if you kept going with this circle, we don't know what the radius is. It's not a unit circle. We know that there's how many radians? Well, we've got 1 radian, 2, 3 radians around the outside. And then we've got 3 more down here. So there's 6 radians in this circle. Okay, the unit circle has little more than 6 radians. And the unit circle has a radius of 1. So let's draw a unit circle here. So the definition of the unit circle. And you can draw this just below that circle that we were just looking at in your notes. The unit circle has a radius equal to 1. Okay, so let's say this is a unit circle. I know it's not perfect, but it's pretty close. This is your unit circle. We've got your x-axis, your y-axis. You've got a radius of 1. So this gives us coordinates of these 4 main points right here at our where the circle crosses the axes. So if this is a distance of 1, my x-coordinate at this point is 1, and my y-coordinate is 0. Then I can go up to the 90-degree angle and say my x-coordinate is 0, because I don't go left or right, I'm just going straight up, and my y-coordinate is 1. And over to the 180, we have -1 for the x-coordinate, and I don't go up at all, so the y-coordinate is 0. And then for the 270-degree angle, it's going to be 0, and then down -1. Okay, so that's what the unit circle looks like, what 4 of the coordinates are going to look like, and we're going to do a lot more with that. Okay, so we're going to skip this for now. We're going to do this later in the week and go to the unit circle discovery. So thinking about that unit circle we just looked at, you've got a circle here. I know it's not perfect. So how do you find the circumference of any circle, not just the unit circle? Well, we know the formula is 2 pi r. And then if it's the unit circle, where the radius equals 1, then the circumference is 2 pi. Okay, so then what does that mean? Well, that means the distance around unit circle, I'll use UC, is 2 pi. It's about 6 point something. Okay, based on what we learned about radians, how many radians is in the entire circle? Well, it's got to be 2 pi, because 1 radian is equal to the distance, the radius of the circle, so it's 2 pi. Okay, so now how do we find the radians in half the circle? So if the whole distance around is 2 pi, what would halfway around have to be? I only went halfway around. Well, that's going to be just half of 2 pi, or pi radians. How many radians is 1/4 of the circle? So if this is pi, at 90 degrees, we've gone half of pi, or 1/2 pi, or pi over 2 radians. And then what about a 45-degree angle? So now we're right here. Half of that half would just be 1/4. And then what about a 60-degree angle? Okay, 60 degrees, how does 60 degrees relate to 180 degrees? What part of it? So in other words, 60 out of 180 is the same as what? If you reduce that, it's 1/3. So this would just be pi over 3 radians. Okay, and then the formulas for measuring, for changing radians to degrees. If we have radians and we want to get degrees, you do radians times 180 divided by pi. And then if you want to get radians from degrees, you go degrees times pi over 180. So those two formulas, make sure you mark those down, because we're going to use those to do the problems that are coming up next. Okay, so we'll do a couple practice problems. So I'll start by doing the first problem in each one for you, and then you're going to be responsible for doing the rest of those. I'll post the answers to these on my wiki. So -300 is my degrees. So I do that times, so our formula was degrees times pi divided by 180. So degrees times pi over 180. And now what you're going to do is take that and reduce it. So 300, -300 divided by 180. Don't put the pi in your calculator. And then you just reduce that if you want to do it by hand, but the calculator, if you have one, will do it for you, is math, enter, enter, and that reduces to -5/3. So now I know this is the 300 over 180 reduces to -5/3, and you just put the pi on top with the -5. So 300 degrees is equivalent to -5 pi over 3 radians. Usually radians have a pi in them. Okay, so down here I'm not going to do one of these. I'm going to do a different one and let you do one. I'm just going to do this one backwards. So let's say I have -5 pi over 3 radians, and I'm going to use my formula. So I multiply radians times 180 divided by pi. Radians times 180 divided by pi. Okay, so now I have a pi in the numerator and a pi in the denominator, so I can cross those off. If you don't have a pi, because in 15, 16, and 17 you won't, then you'll end up dividing by pi in your final answer. But in this case, we don't have a pi to worry about here. So now I have negative 5/3 times 180. Okay, so you could figure out, put negative 5/3 in as a fraction and multiply that by 180, or do negative 5 times 180 divided by 3. So negative 5 times 180 divided by 3, and you get negative 300, which is what we should have gotten. And that equals negative 300 degrees. So now we switch this answer we got for number 6 back. So this is how you would do 12 through 17. And again, I will post the answers to these problems on my wiki page. Just go ahead and look for those after you're done with the video. Okay, the last part of the lesson involves putting our unit circle together. So to start with, we're going to take our 45-degree angle circle, and we're going to mark it with the key points. So remember, your key points were those 4 we did earlier. You had your 0, 360, you had your 90, 180, and 270. So let's put those in. So this is 0, 360, 90, 180, and 270. Okay, now we need to put in the radians that go with each of those key angles. So we know this is still 0 radians, and we just figured out that this was 2 pi radians. So now, and we also knew that 180 was pi. We figured out that 90 was pi over 2. That goes back to the discovery you did earlier, if you need to refer back to that. Now to figure out 270, you can just use your formula. So 270 times pi divided by 180, and that should reduce to 3 pi over 2. So 3 pi over 2. Okay, now we need our 45-degree angles. So at this point, this is halfway from 0 to 90, so that's 45. And now, what are the radians that go with 45? Well, you figured out earlier that that was pi over 4. So then we skip the 90, but we have to add 45 degrees to get the measure of this angle. So that would be 135 degrees. And now you can do the same thing. 135 divided by 180, reduce it. Or you can notice that each one of these pieces is 1/4 of a pi, 1/4 pi. So if this is 1/4, this would be 2/4, this would be 3/4. So in other words, it would be 3 pi over 4. So again, 2 ways to get the radians. You can use the formula, or you can just count using the parts of the pieces of the pie that you know. So then we've got 180 plus 45 or 225 degrees. And then that's going to be 3, 4, 5 pi over 4. And then 270 plus 45 is 315 degrees, or 7 pi over 4. Okay, so those are your 45-degree angles. Now we're going to do the 60-degree angles. So you've got still your key angles. You've got 0, 2 pi, 0, 360. You've got 90 and pi over 2. You've got 180 and pi, and you've got 270 and 3 pi over 2. Okay, and now we know these are 30, these go up by 30s, so you've got 30 degrees, 60 degrees, and then we also figured out that this was pi over 3 already. Now, this is 30 out of 180, 30 degrees over 180, so what fraction is that going to reduce to? Well, it's going to reduce to 1/6. So this would be pi over 6. And now as we count up, we just add 30 degrees every time, so 90 plus 30 is 120. And if you put that in your calculator, you would see that this is 2 pi over 3. And this is 150 degrees. So we've got 1, 2, 3, 4, 5 pi over 6. And then as we go up, this is 210 and 240. So this is 7 pi over 6. And this was 5, 6, 7, 8 pi over 6, 4 pi over 3. And then this one is 300 and 330. And this one is 5 pi over 3. And this one will be 11 pi over 6. Okay, so between those two circles, you've got your 45-degree angles and you've got your 30 and 60-degree angles. You need to flip over your page and fill in the degrees and radians for each of those angles. That's part of your assignment for today. So if you go to this one and start filling it in, you've got your 0, 360, 0, 2 pi. Move up to this. This was 30 degrees and pi over 6. This was 45 degrees, pi over 3. This was 90 degrees, pi over 2, etc. Just put the two circles together. I believe that I'm going to have to stop there because I think we get out at 12:26 now, right? I'll just finish it later.